Welcome to WAN Concept. As we all know, local area networks are called LANs. The name implies that your LAN is local to you and your small home or office business. But what if your network is for larger business? Perhaps even a global enterprise. You cannot operate a large business with multiple sites without a wide area network, which is called a WAN. This module explains what WANs are and how they connect to the internet and also back to your LAN. Understanding the purpose of and function of WANs is foundational to your understanding of modern networks. So let's jump into WAN concept. What you will learn in this module. So the title of this module is WAN Concept, and the module objective is to explain how WAN access technologies can be used to satisfy business requirements. The first one is the purpose of WAN, and explain how WANs operate, traditional WAN connectivity, modern WAN connectivity, and internet-based connectivity. So whether at work or at home, we all use local area networks. However, LANs are limited to a small geographical area. A wide area network, or WAN, is required to connect beyond the boundary of the LAN. Hence, a WAN is a telecommunications network that spans over a relatively large geographical area. A WAN operates beyond the geographical or geographic scope of a LAN. As you notice in the figure, WAN services are required to interconnect an enterprise campus network to remote LAN at branch site, telecommuter sites, and remote users. So this table highlights the differences between LANs and WANs. LANs provide networking services within a small geographic area, while wide area networks provide networking services over large geographical areas. LANs are used to interconnect local network computers, peripherals, and other devices. And WANs are used to interconnect remote users, networks, and sites. A LAN is owned and managed by an organization or home users, while WANs are owned and managed by internet service, telephone, cable, and satellite providers. Other than the network infrastructure cost, there is no fee for use or to use a LAN. But WAN services are provided for a fee. LANs provide high bandwidth speeds using wired communication. Or LAN provides high bandwidth speed using wired Ethernet and Wi-Fi services, while WANs providers offers low to high bandwidth speeds over long distances using complex physical networks. The private and public WANs. WANs may be built by a variety of different types of organizations as follows. An organization that wants to connect users in different locations, an ISP that wants to connect customers to the internet, and an ISP or telecommunications that wants to interconnect ISPs. A private WAN is a connection that is dedicated to a single customer that provides guaranteed service level, consistent bandwidth, and security. While as you notice in the figure, that's an example of a private WAN. a connection is dedicated to a single customer. That is why it is guaranteed a service level and consistent bandwidth and security. However, the public WAN connection is typically provided by an ISP or telecommunication service provider using the internet. In this case, the service provider levels and bandwidth may vary, and the shared connection do not guarantee security. WAN topologies. Physical topologies describes the physical network infrastructure used by data when it is traveling from source to a destination. And the physical WAN topology in WANs is a complex and for the most part unknown to users. Consider a user in New York establishing a video conferencing call with a user in Tokyo, Japan. Other than the user's internet connection in New York, it would not be feasible to identify all of the actual physical connection that are needed to support a video call. Instead, WAN topologies are described using logical topology. A logical topologies describe the virtual connection between the source and the destination. So WANs are implemented using the following logical topology designs. Number one is the point-to-point topology. A point-to-point topology, as shown in the figure, employs a point-to-point circuit between two endpoints. And point-to-point link often involve dedicated leased line connections from corporate edge point to the provider networks. And a point-to-point connection involves a layer 2 transport through the service provider network. Packets sent from one site are delivered to the other site and vice versa. A point-to-point connection is transparent to the customer network. It seems as if there is a direct physical link between two endpoints. It becomes expensive if many point-to-point connections are required in this kind of topology. The second one is the hub and spoke topology. In a hub and spoke topology enables a single interface on a hub router to be shared by all spoke circuits, as shown in the figure. Spoke routers can be interconnected through the hub router using virtual circuit and routed sub-interfaces. So it is being configured in the router, in the hub router, the virtual circuit and routed sub-interfaces. The figure displays a sample hub and spoke topology consisting of three routers connecting to a hub routers across one cloud. A hub and spoke topology is a single home topology. There is only one hub router and all communication must go through it. Therefore, spoke routers can only communicate with each other through hub router. Consequently, the hub router represents a single point of failure. If it fails, inter-spoke communication also fails. The other topology, one topology is the dual home topology. A dual home topology provides redundancy. As shown in the figure, two hub routers are dual home and redundantly attached to three spoke routers across a one cloud. And the advantage of dual home topology is that they offer enhanced network redundancy, load balancing, distributed computing and processing, and the ability to implement backup service provider connection. The disadvantage is that they are more expensive to implement than single home topologies. This is because they require additional networking hardware such as additional routers and switches. Dual home topologies are also more difficult to implement because they require additional and more complex configurations. As you can see in the figure, it shows a dual home topology, a cloud with two hub routers on one side and each connecting separately to three spoke routers, spoke A, spoke B, and spoke C through the cloud. And another one topology is the fully meshed topology. The fully meshed topology uses multiple virtual circuits to connect all sites as shown in the right figure. This is the most fault-tolerant topology of the five type of WAN topologies. For instance, if site B lost connectivity to site A, it could send the data through either site, C or D. And another one is the partially meshed topology. The partially meshed topology connection may be many, but not all sites. As you can see in the figure, sites A, B, C is still fully meshed, but site D must connect to site A to reach site B and C. Moving on to the carrier connections, another aspect of WAN design is how an organization connects to the internet. An organization usually signs a service level agreement with service provider, or the SLA outlines the expected services relating to the reliability and availability of the connection. The service provider may or may not be the actual carrier. A carrier owns and maintains the physical connection and equipment between the provider and the customer. Typically, an organization will choose either a single carrier or a dual carrier WAN connection. A single carrier WAN connection is when an organization connects to only one service provider. As shown in the first figure, an LSA is negotiated between the organization and the service provider. The disadvantage of this design is the carrier connection and service provider are both single point of failure. That means the connectivity to the internet would be lost if the carrier link or the provider router failed. However, in the dual carrier connection or dual carrier WAN connections, it provides redundancy and increases network availability, and organization negotiates separate SLAs with two different providers. The organization should ensure that the two providers each use a different carrier. Although more expensive to implement, the second connection can be used for redundancy as a backup link. It could also be used to improve network performance and load balance internet traffic. So the evolving network requirements of a company can be changed dramatically as the company grows over time. A network must be met the day-to-day operational needs of business, and it must be able to adapt and grow as a company changes. Network designer and administrator meet these challenges by carefully choosing the network technologies, protocols, and service provider. Network can be optimized by using a variety of network design techniques and architectures. So we can categorize the network as a small network, a small fictitious company started with a few employees in a small office, uses a single LAN connected to the wireless router for sharing data and peripherals, and connection to the internet is through common broadband service called digital subscribers line. IT supports contracted from the DSL provider. So this kind of network is considered small network, as only minimal WAN devices are involved. Another type of network is the campus network. Within a few years, span grew and required several floors of a building. The company now required a campus area network. A firewall secures internet access to corporate users, in-house IT staff to support and maintain the network. So as the network grows, the personal requirements is also needed, like the IT support, and then some additional security on the network has been added, like the firewall, to protect the internal network. And another classification is network can be a branch network. That means to say, a few years later, the company expanded and added a branch site in the city and remote and regional sites and other cities. So as the network becomes grow from small, medium, it becomes having a branch network. The company requires a metropolitan area network, or MAN, to interconnect sites within the city. To connect to the central office, branch office in nearby cities, use private dedicated lines through their local service provider. So if the company really grows much more, it expand to a branch offices, which makes the network becomes more considered as an enterprise network or the branch network. As it grows, it expands to a branch office, regional office, remote office, and central office. So these are the classification of network as it grows from small to medium up to the branch network. And from the branch network, it becomes distributed network and spans engineering. For example, engineering has grown in business for 20 years. Site to site, it becomes site to site, and remote access virtual network has been implemented and enable the company to use the internet to connect easily and securely with employees and facilities. So as the company grows and grows through the years, it becomes a distributed network because it spans a very huge coverage of network. All right, so that's it for the WAN concept. I hope you will continue to watch the wide area network concept on the next video.